So let's look at coordinate geometry of the line, and we'll start by looking at how to find the length of a line between 2 points A and B. Well, the formula to find the length of a line between 2 points A and B is given by the square root of x2 minus x1 all squared plus y2 minus y1 all squared. Where do we get the x1, x2, y1, y2 points? Well, we have a point A. It has an x and y coordinate on the Cartesian plane. And we have a point B with an x and y coordinate on the Cartesian plane. So to distinguish between the two, we simply call the point A values x1, y1, and the point B values x2 and y2, and we can plug these then into the formula. Okay, so for example, find the distance between the point A, whose coordinates are at x is 2 and y is minus 4, and the point B with coordinates at x is 3 and y equals 1. So the first thing we do is we nominate this point A our x1 and y1 values, and point B our x2 and y2 values. We plug those into this equation here, and we see that the length of the line, or the distance between the points A and B, is equal to the square root of 26. We might also be asked to find the midpoint of a line, okay, or the midpoint between 2 points A and B. And again, for example, find the midpoint of the line segment joining the point A with coordinates at minus 1, 3, and point B coordinates at 5, 7. Well, we note this as our x1, y1 coordinate, and the point B our x2, y2, and we simply plug in our values into the formula, and we see that the midpoint between the point A and B is at 2, 5, where x is 2 and y is 5 on the Cartesian plane. Now, a more interesting problem would be something like, if the distance between the points 2, 3 and 5, k is equal to the square root of 10, find two possible values of k. Well, we know that the formula for distance is given by this formula here. We know from our question that the distance is root 10. If we take our 2 points 2, 3 and 5, k, and we nominate them x1, y1, x2, y2, and fill those into our equation here, we will end up with something like the root 10 is equal to the square root of 3 squared plus k minus 3 times k minus 3. So that means if we were to multiply out this expression, remove the brackets, we would have 3 squared is 9, and k by k is k squared minus 3k plus 9 here. Simplify that expression and we get k squared minus 6k plus 18. And if we say that the root of 10, square root of 10 is equal to square root of all of this, then if we square both sides, then we can say that 10 must be equal to simply k squared minus 6x plus 18, i.e. what's inside the square root sign here. Okay? Simply by squaring both sides here, we can remove the square root signs and just reveal what's inside and underneath each. And if 10 is equal to k squared minus 6k plus 18, then it follows that k squared minus 6x, bring over your 10, plus 18 minus 10 plus 8 is equal to 0. Okay, and now that we have this expression, k squared minus 6k plus 8 equals 0, we just find the factors of that expression. So we know that the factors of k squared are k by k, i.e. k multiplied by k gives k squared, and factors of 8 are 8 and 1 and 2 and 4 as well. So we'll go with 2 and 4 here because we're looking to make minus 6. Okay. Now, what's the story here? It's a positive sign here. So what will the sign of our factors be? Well, they'll be the same. What will they be? We look here, they'll both be minus. So the factors of k squared minus 6k plus 8 are k minus 4 and k minus 2. And we simply let them equal to 0 because that's what we have here in our expression. So if we let k minus 4 equal 0, k must be equal to 4. Or if k minus 2 equals 0, k must be equal to 2. And these are the two values of k for the solution to this problem. Let's look at the slope of a line. Well, when we have a Cartesian plane, we have an x-axis and we have a y-axis. Okay, and we can describe our x-axis as the run and our y-axis as the rise. And if we have 2 points A and B and we join the line between A and B, that line has a slope or a rate of change, and that slope is equal to the value of the rise, the difference in the rise, over the distance between, or in the difference in the run. So the slope is the rise divided by the run. Or we can say that the slope is the change in y from here to here divided by the change in x. And so the formula we get actually is the y2 minus the y1 value divided by the x2 minus the x1 value there. And that's the formula for the slope m of a line. And let's just remember or note that slope means how much y changes for a 1 unit change in x, or it's the rate of change of y with respect to x. Slopes can be positive and slopes can be negative. Okay? Two lines, if they're parallel, have equal slopes, and if they're perpendicular or at 90 degrees to each other, then we can say that if we have a line A perpendicular to a line B, then mathematically we can say that the slope of A times the slope of B will always be equal to minus 1 for lines that are perpendicular. So the type of problem we might meet with the first one, the line L contains the points 1, 1 and 2, 4. So we call this x1, y1, x2, y2. The line M contains the points 4, 1 and 3, minus 2. Find out or investigate if the line L is parallel to the line M. Well, to know if they're parallel, we need to see if their slopes are equal. So M subscript L, the slope of L, is equal to 3 by plugging in our values. And the slope M subscript M, the slope of M, is equal to 3. Therefore, ML is equal to MM. The slope of L is equal to the slope of M. Therefore, the line L is parallel to M. Another example. Slope of the line L is 3 over 4. What is the slope of the line M if it is parallel to L? Well, if it's parallel, the slope is the same, so the slope of the line M would be 3 over 4 as well. What would the slope of a line N be if it were perpendicular to L? Well, to find that, we have to use the equation or formula that the slope of L times the slope of N must be equal to minus 1 if they're perpendicular. Okay, so that would mean that 3 over 4 times Mn, which is our slope of N, is equal to minus 1. So that would mean that if we divide both sides by 3 over 4, Mn is equal to minus 1 divided by 3 over 4. And that's the same as minus 1 over 1, just to balance it up, times multiplied by 4 over 3, because we invert this, we go from division to multiplication of fractions. And that gives us minus 1 times 4 is minus 4, and 1 times 3 is 3. So the slope of a line N perpendicular to L, whose slope is 3 over 4 would actually be minus 4 over 3. And here's a third example to do with the slope of a line. If the slope of a line through the points 3, 2 and 8k is 3 over 5, find k. Well, the slope is equal to y2 minus y1, x minus y1, so 3 over 5 is equal to k minus 2 divided by 8 minus 3, because we've just plugged this y2 value into our formula here. Okay? So we solved that with 3 over 5 is k equals k minus 2 divided by 8 minus 3. So 3 over 5 is equal to k minus 2 over 5, which is 8 minus 3. And 5 threes are 15, is equal to 5 by k minus 2, which is cross-multiplied there to get this line here. So 15 is equal to 5k minus 10, that's there. So 15, bring over the minus 10, becomes plus 10 is equal to 5k, which we've isolated, we want it on its own. 5k must be equal to 25, k must be equal to 5. Let's look at this line here. This line, it's a line with 4 points. 0, 5, 1, 4, 2, 3, and 3, 2. And if you notice that for all of these points, the x value plus the y value is equal to 5. That is the equation of the line. And this equation is known as a linear equation. And we can find the equation of any line if we're given its slope m and just one point on the line, x1, y1. And to do that, we'd use a formula to find the equation of a line in terms of y and x and the number if it exists. By using the formula y minus y1 equals m times x minus x1. So let's look at this problem here. Find the equation of a line of slope m is equal to 2 over 5 and with a point minus 3, 2. So we take our x1, y1 value in our slope m and we plug that into our formula. Y minus y1 equals m times x minus x1. So we have y minus 2 because we've y minus y1 and that's our y1 value there equals m, it's 2/5, which we have from here, times x minus x minus x1, so that's x minus minus 3, that's there. Be careful, minus by minus gives us plus here, so y minus 2 equals 2 over 5 times x plus 3. Now this 2 over 5, it's a bit unsightly, we want to lose it if we can, and to do that we can multiply all the terms by 5. This is a very, very important step in algebra, and we're using it now in coordinate geometry, but we want to lose the 5 here, so we just multiply every term by 5. Okay, we'll do that over here in a second. So we have 5 times the y minus 2, which is there on the left, is equal to 2/5 by x plus 3. That was there already, and we multiply that whole term by the 5 as well. So multiplying through, 5 by y is 5y, minus 10 is equal to this 5 cancels with this 5, 2 times x plus 3. So 5y minus 10 is equal to 2x plus 6. And we can keep the x positive. We have 5y minus 10 is equal to 2x plus 6. So just keep the x positive over on the right hand side here and bring all the other terms over. So we have 2x plus 6 minus 5y plus 10 is all equal to 0 on the left side, and that's fine. Or we can just rewrite it the other way. So we have 2x plus 6 minus 5y plus 10 equals 0, to leave us with our equation, which is equal to 2x minus 5y plus 16 equal to 0. Another way to express a linear equation is in the form y equals mx plus c, y is equal to the slope times x plus this constant c. And the constant is where the line cuts the y-axis, and the m is the slope. So often we look to turn an equation of a line like 2x minus 5y plus 16 equals 0 into the form y equals mx plus c, because if we can do that, we then can immediately glance at this new equation and say, well, the slope is this, and it cuts the y-axis there. Okay, so how do we do that? Let's turn 2x minus 5y plus 16 into the form y equals mx plus c. So we need to have y on its own, so we bring over the minus 5y over to here, it becomes plus 5y. Okay, so 2x plus 16 is equal to plus 5y. Now let's just rewrite it so that the y is on the left. So 5y is equal to 2x plus 16, same thing, just written the other way around. So we now want to isolate y by itself, so it's just y equals, and we have 5 times y. To get rid of that 5, we simply divide all the terms in the equation by 5. Do unto one, do unto the others. Okay? So 5 cancels out, so we have y is equal to 2 over 5 by x plus 16 over 5. 2 over 5 is our slope, and 16 over 5, or 3.2, is where the line cuts the y-axis at 3.2. So if this was the y-axis, and this is the x-axis, you have 1, 2, 3, and it would cut there at 3.2. So let's look at an example of a few key points, just in kind of one go, in one example. Okay. The equation of the line AB is given by 5x minus 3y equals 26. Find the slope of AB. Well, to do that, we should really rewrite this in terms of this expression, in terms of y equals mx plus c. We have to rewrite it like this somehow. Okay. So we need to isolate the y. So we have 5x minus 3y equals 26. So 5x minus 26 is equal to 3y. Or 3y is equal to 5x minus 26. Remember what we did before? To isolate y by itself, we simply divide every term by the coefficient of y in the expression. That's 3. So that these cancel out to give us y equals 5 over 3x minus 26 over 3. The slope of the line is 5 over 3. Part 2. Point A has a coordinate 4 minus 2, and a point C has a coordinate minus 6, 4. Prove that the line AC is perpendicular to AB. So we need to show that the slope of AC times the slope of AB is all equal to minus 1, from the formula from before. Okay? The slope of AB is 5 over 3. The slope of AC we can find using the slope formula. Okay? And we can find that the slope of AC is equal to minus 3 over 5, simply by plugging in the coordinate values x1, y1 for an x2, y2 for AC into the formula here, gives us minus 3 over 5. Okay, so let's just move up here. So if they're perpendicular then, one by the other must be equal to minus 1. So is 5 over 3 times minus 3 over 5 equal to minus 1? And yes, they are, because 5 goes into itself once there, 3 into itself once there, 1 by 1 is 1, by minus 1 is minus 1. So they are. And the second part of this problem then says find the equation of the line, so bear with me. Find the equation of the line AC in the form ax plus by is equal to c. Okay, so it's just the general form. It's not the y equals mx plus c. It's just the general, I would say, unwieldy equation of the line. So we have the slope, and we have a point. We can plug those into the original equation to find the equation of the line, and we find that we end up with a term that looks like y plus 2 is minus 3 over 5 times x minus 4. We want to get rid of the 5, so we need to here so that we can clean the expression. So we multiply every term by 5, multiply this term by 5, as we're doing here, and we multiply all of this by 5, as we're doing here. Okay? And you'll see that this cancels with this. Okay, and we will end up with 5 by y is 5y, and 5 by 2 is 10, and minus 3 by x is minus 3x, and minus 3 by minus 4 is plus 12. So 5y is equal to minus 3x plus 12 minus 10, bringing our 10 over. 5y is equal to minus 3x plus 2. Y is equal to minus 3 over 5x plus 2 over 5. This is in one form, but we could also rewrite the equation or have it in this form here, where we could have brought the 3x over here plus 5y equals 12 minus 10, and would have 3x plus 5y is equal to 2, which is how they actually asked us for initially. And just note here now, we're looking towards graphing lines quickly now. We can just do some quick plots on a Cartesian plane very quickly. But before we do that, if we take a line that passes through x is equal to 2, you'll notice that the x coordinate of every point on the line is equal to 2. And the equation of that line is x equals 2. If we were to take a line that passed through here, parallel to the x-axis, at y equals 2, you'd notice that every point on the line here, every y coordinate would be equal to 2, and that line is y equals 2. This is the line x equals 1, the line x equals 6. The equation of this line is y equals 6, y equals 4, x equals 3, and so on. Also, it's important to note that all lines will cut the x and the y-axis somewhere, where however they're plotted, they'll always eventually cut the x and the y-axis somewhere. Okay? And if that's the case, it's just good to know, or important to know, that a line will cut the y-axis at x equals 0, and it will cut the x-axis at y equals 0. So if we want to quickly find 2 points on a line, we can, when we're given an equation, we can let x equal 0 and plug that into our equation, find its corresponding value of y, and we can let y equal 0 and find its corresponding value of x. We'll see an example of this in a moment. So for example, find 2 points on the line 2x plus 3y equals 6. Simply let x equal 0, plug that into your equation. So instead of 2x, you've 2 by 0 plus 3y equals 6. So 2 by 0 is 0, plus 3y equals 6. So y must be equal to 6 over 3. Y equals 2. The first point is 0, comma 2. Your x was 0 from the beginning, and its corresponding y value is 2. That's 1 point on that line. The next point, we let y equals 0, plug that into the equation where we see y. So 2x plus 3 times 0 is 6, 2x equals 6, x is equal to 2, x is equal to 3. Our second point is 3, 0. A quick plot, x, y axis, 3, 0, 0, 2. That's a very quick plot of that line. Lines containing the origin. If an equation looks like x plus 2y equals 0, i.e. There's no independent term like x plus 2y plus 5 equals 0. There's no independent term there like a plus 5. So if it looks like that, this means that it goes through the origin. In other words, 0, 0 is the point on the line. So to find another point on the line, if we wanted to quickly plot it, we can just pick any old value of x and see what its y value is. So just say let x equal 2 and sub that into the equation. So if x equals 2 and this is our equation, then our x is 2 plus 2 times y equals 0. So 2y is equal to minus 2, y is minus 2 over 2, y is equal to minus 1. So therefore x is 2 and y is minus 1. That's another point on the line. 0, 0 is a point on the line. You can now quickly plot or graph that line. How do we verify if a point is on a given line? Is 3 comma minus 2, is that point on the line given by the equation x plus 2y plus 1 equals 0? How do we tell? We just plug in 3 for x, minus 2 for y, and we see does it indeed equal 0, and we can see here that we've 3 minus 4 plus 1, 3 minus 4 is minus 1 plus 1 equals 0, so yes, it satisfies the equation. 3 comma minus 2 is definitely on that line. More interesting problem here. If the point k comma 3 is on the line 4x minus 3y plus 1 equals 0, find the value of k. Well, we sub k in for x and we solve for x. So 4 times k and 3, in for y. So 4 times k minus 3 by 3, which is our y value, plus 1 equals 0. So 4k minus 9 plus 1 equals 0. 4k minus 8 equals 0. 4k is equal to 8. K must be equal to 2. To find where two lines, the line x plus y equals 4, intersects with the line x plus 3y equals 6. To find that point of intersection, you solve the two equations simultaneously here. So you just simply write x plus y equals 4 over x plus 3y equals 6. Now, we can't just cancel unless we change the sign. So we've x minus x, they'll cancel. But if we change the sign of one, we must do unto all the others. We change the sign of all the terms here. So these two cancel. Y minus 3y is minus 2y. 4 minus 6 is minus 2. So y is equal to 1. And we then sub that value back into the first equation, x plus y equals 4. So we actually get x plus 1, because that's our value of y, equals 4. X equals 3. The intersect of those two lines is at 3 comma 1, and you can see here it is indeed at 3 comma 1, which we found we could do it graphically like this or mathematically like that. Now we can find the area of a triangle defined by 3 points on a Cartesian plane using a formula if one of the points is at 0, 0. And the formula is that the area of a triangle with 1 point at 0, 0, one point at 0, 0 and 2 other points, x1, y1, x2, y2, the formula is the area is equal to half the absolute value of x1 times y2 minus x2 times y1. And when we use the term abs value, we mean that the abs value of minus 6 is actually 6. Okay, it doesn't matter if it's positive or negative, it's 6. Okay, the abs value of minus 127, the absolute value of that is 127, because if the area, if we find when we plug everything in here that the area is minus 9, well, you don't have a minus 9 area. The area is the abs value of minus 9. It's 9, or 6 in that case. So here's an example. Find the area of the triangle with the points 0, 0, one's at the origin, minus 2, 1, 3, comma 4. So you simply note the first point x1, y2, the second point x2, y2, and plug those values into the formula, and you'll get the area equal to a half the absolute value of minus 11, which is half of 11 is 5.5. A more interesting one then is you might be asked for something like, just bear with me a second, you might be asked for something like, find K if the area of a triangle is equal to 7 and that triangle has the points 0, 0 at the origin, 4, 3 and the point 6, K. So you simply let the area equal to a half x1 by y2, 4 by k, minus 18, so the 18 which is x2 by y1 here. That means that 7 is equal to a half 4k minus 18. So that means that 14 is equal to 4k minus 18. So 14 plus 18 is 32 is equal to 4k. K is equal to 8. But what if none of the vertices are at the origin? We can't use the formula unless one point is at the origin, one of the vertices at the origin. So we have to transform or move the whole triangle so that one point is at 0, 0. And knowing what it takes to move one point, we apply this to the other 2 points. So look at this triangle here then, 2 with points, 3 points at 2, 4, 7, 3 and 4, 1. Let's transform or move the point 4, 1 down to 0, 0. And to do that, we've said 4 minus 4 is 0 and 1 minus 1 is 0. So for the next point we have to say 2 minus 4 is minus 2 and 4 minus 1 is 3. So that's our that's our transformed point. This is our first transformed point at the origin where we want it. And we've 7 minus 4 is 3 and 3 minus 1 is 2. And that's our third transformed point. So we've now shifted the triangle so it's anchored at the origin, and we can use these 2 points here, as our x1, y1, x2, y2 into our formula, and you'll find that the area of the triangle is 6.5.